In our fast-paced digital world, different parts of a software program need to talk to each other. For example, consider online shopping site. You have a user interface where customers choose products, a payment system to handle transactions, and a shipping system to manage deliveries. These systems need to communicate with each other. But how do we ensure this communication is seamless, secure, and efficient? This is where Microsoft Azure Messaging Service steps in. The goal of any messaging service is to decouple your applications so they can scale horizontally. And for communication, we employ messaging techniques where one application sends message to another application and another application receives it and acts accordingly. In this video, we will understand what are Azure messaging services. Mainly, we will look into the most frequently used solutions: Azure Service Bus, Azure Event Grid, Azure Event Hub. We will look into the real-time use case. We will also understand how to identify right messaging service to support your workload. By the end of this video, you will be able to choose the most suitable messaging service to support your business scenario. Now, first, let's understand the Azure messaging services in simple terms. Think of Azure messaging services as a kind of digital post office. It helps to send the messages from one entity to other entity. Post office deals with many kinds of messages, for example, letters, packages, and parcels. And they are in different shapes and sizes. They use different transport mechanisms to deliver these messages. Based on the message type, size, priority, and how many, they choose transport mechanism that suits the best. Some are small and need to reach super quickly. Some are huge, but there is no hurry for them. While there could be whole bunch of messages just to one entity. So they have to use either their van, train, or flight based on their requirement. Here, the mode of transport is Azure Messaging Services, nothing but Service Bus, Event Grid, and Event Hub. They will pass the message from source application to the destination application. Now, which Azure message services we want to use? So to decide the right messaging services, we need to understand the message. What is the message? We need to define it, its size, how many messages, who is getting them, how often they are getting it. If we know the answers to these questions, we will be able to choose right solution. Let's understand how we can categorize this. In Microsoft messaging world, a message is briefly categorized into two: commands and facts. Facts are further categorized into time series facts and discrete facts. First, let's understand the commands. It is a directed instruction to some service to go and do something. If we have these sorts of messages where we want to issue a command via a message, it should use a message broker such as Azure Service Bus. You issue a command via message and place it in either queue or topic so the listener will pick it up and process it. Some of the most common used use cases are message-based communication between decoupled software components, organizing and managing distributed transactions in microservices, load balancing the message processing. It is also used where order of the processing is a key. Now, let's look at a simple use case as an example. Order processing in e-commerce application. When a customer places an order, they are essentially sending a command to the system, for instance, place order. This command then triggers order processing workflow in the system. The command indicates the intention to change the system's behavior, in this case to create a new order. We have two software components here which are kind of decoupled. Component on the left hand side deals with issuing a command to place an order, whereas component on the right hand side deals with order processing workflow. Now let's look at the time series facts. Any telemetry data that is relying on the time series. A better example would be sensor data. You have a sensor that sends the temperature to you every second. This will be a huge amount of data and you want to analyze incoming data and generate alerts when the temperature reaches certain threshold. This is where the Event Hub comes into the picture. Event Hub is a big data streaming platform and event ingestion service. It can receive and process millions of events per second. You can read these events as a batch and do real time processing or any kind of business intelligence offline. Most common use cases are telemetry data aggregation from sensor devices such as IoT devices, real time analytics over streamed data archival for anomaly detection. Let's look at an interesting use case. Suppose we have sensors placed in different areas of a forest to detect and track forest fires. These sensors capture data such as temperature, smoke levels, humidity, wind direction, and wind speed. This sensor will provide real time data every minute via API. This will be a huge amount of data. We can use Azure Event Hubs to process these incoming stream of data in real time. Based on this data, we can raise real time alerts when there is a serious fire, or we can build business intelligence reports offline. If you look at here, this is most commonly used use case. You could have any sensor device. Usually the sensor devices will provide you the data via APIs. For data ingestion into the event hub, you could use any integration solutions. For instance, Azure Logic Apps. The Logic App could pull the data from the sensor devices via API and it can ingest the data into the event hub. Now, on the other side, to process this data, we could use real-time analytics provider. In this case, it could be the Stream Analytics. So it could process the data and generate the alerts based on the incoming metrics. It can also ingest the data into Azure Data Explorer. Here, the Azure Data Explorer is a fully managed data analytics platform. We could build Power BI reports on top of it for the business intelligence requirement. The next one is discrete facts. This is like a new user signed up to your service or someone logged into a computer from a different location and you need to trigger a whole bunch of security protocols to make sure it is legitimate. These are exactly point in time events and this is where you can use Event Grid. Event Grid is all about reactive programming. It allows you to build applications that react to events happening in your application or even in other Azure services. It is like an automatic trigger mechanism for certain events. And the common use cases are reacting to status changes in Azure services, automating business processes and workflows, integrating with external services or on premises applications. For example, in the previous case, in an e-commerce application, we considered the Azure Service Bus to process the order. Once an order is processed, we might want to do a whole bunch of other things like update stock, schedule delivery, and issue invoices. Once the order is processed, the order processing workflow can raise an event. The order is placed. Now, on the other side, we could have different components reacting to this event. Inventory component to update the stock, delivery component to schedule the delivery, and billing service to issue the invoice. They react to the event the order has been placed. Let's take a pause here. You might be thinking we can achieve the same by Azure Service Bus. Simply issue a command into Azure Service Bus topic and you could have a subscriber as inventory component, delivery component, invoice component to kick off each of these processes. You can certainly do that. But commands and events are two different things. When you issue a command to place an order, you have kind of a tight dependency between sender and receiver. Whereas event is something has already happened. Do what you want to do next. Sender don't really care. This is why I said we need to understand and define our messages. Also, Azure Service Bus, Event Grid, and Event Hub, they come with their own set of features and capabilities. Event Grid uses a specific event schema, which makes it easier to handle events across different services. This is particularly helpful in environments where you have events coming from many different sources. Event Grid is designed for high volume, low latency scenarios, and it can send same message to many recipients. While Service Bus also supports multiple subscribers with the topics, Event Grid is generally more suited to distributing the same event to many listeners. Both Service Bus and Event Grid have strong delivery guarantees, but their strategies are different. Service Bus will implement retries for a specific interval, and if the message still can't be delivered, it is placed in a dead letter queue. Remember, I talked about sender and receiver dependency before? This is what it is. Event Grid, on the other hand, will keep retrying to deliver the event for up to 24 hours. And this is another important difference. Service Bus uses a pull based model where the receiver actively checks for new messages. On the other hand, Event Grid uses a push based model where the events are sent to the event handlers as they occur. This makes Event Grid more suitable for real time event handling. Event Grid allows you to filter events on the server side, meaning only events of interest are sent to your service. With Service Bus, all messages are delivered to the subscribers and the filtering has to be done on the client side. To conclude which one to pick, you need to define the message. Remember, we talked about the digital post office example in the beginning. Understand and define your message. Who is the sender and receiver? What is the message size? How many messages? How often we are sending or receiving the messages? How soon the receiver need to process them? Then we also need to understand the capabilities of each of the messaging service and do the mapping to choose the right service for your workload. That is it for this video. I will be making more videos on each of these individual components.